In our previous lesson, we talked about the fundamental theorem of calculus. Today, we're looking at kind of a corollary to it. It's called the second fundamental theorem of calculus. And basically what it is about undoing an operation. Back in elementary school, you did addition and then undid it with subtraction to get back where you started. Multiplication, you undo with division. Well, we've already talked, integration and taking a derivative are inverse operations. And pretty much all this theorem says is that when you take an integral, then take a derivative, you get right back where you started. So, kind of to show it, I'm having a function here, cosine of t, and I want to take the integral of it. And this is how I'm going to take the integral of it. The integral from some number, in this case I'm making pi over 2 up to x, of the function cosine of t. Well, I take the antiderivative just like normal with the first fundamental theorem of calculus. So, I'm sorry, the integral of cosine of t should be sine of t, evaluated from pi over 2 to x, which means I just plug in those values. I plug in sine of x minus sine of pi over 2. I honestly don't remember what sine of pi over 2 is. Well, I do. I just don't care what it is, and here's why. Because what I'm going to do is I'm going to take this guy I just found and go backwards. I want to now take the derivative of that guy. So the derivative of sine is cosine. Sine of pi over 2, when I take the derivative of that, well, it's just a number. The derivative of a number is nothing. So notice what just happened. My final answer ended up being eerily similar to what I began with. Cosine, cosine. It was cosine of t, now it's cosine of x. So, you would think just when you take cosine, or when you take the integral, take the derivative, you always get exactly what you started with. And that's the one part where calc is a little bit different, because it's not always the case. Let's look at this problem where I go, the only difference now is instead of going to x, I have an upper limit of x cubed. Well, it's still the same thing. I have sine of t evaluated now from pi over 2 to x cubed. So I'm just going to plug in like I did before, sine of x cubed minus sine of pi over 2. When I take that derivative back, the same way as before, except sine of pi or x over 3, or x cubed I mean, that's like x cubed inside and outside. That means we have a chain rule. Derivative of the outside is cosine with respect to the inside, so the inside stays the same, times derivative of the inside, times 3x squared. And this guy right here, negative sine of pi over 2, again, is just a number, so that part goes away. So my answer here is just a little bit different here. It's not the exact same as how I started. Something changed. Well, where does the difference show up? It's in this last guy right here. In this case, I'm multiplying by 1. Why is that the case? Because the derivative of this top guy is just a 1. What's the derivative of this x cubed? It's 3x squared, which is what comes up right there. And that's what the second fundamental theorem of calculus states. All I have to do this shortcut is I literally take the guy up top, plug it into my function, and then multiply by the derivative of this top guy. So in this case, the derivative of x would just be 1. In this case, the derivative of x squared would be 2x. That's why I need to multiply at the end. So just to look at some other examples and how simple it really is. What I'm going to do here, I'm taking the derivative of an integral. So t squared, I'm literally just going to go and plug in sine of x for t. So sine of x squared instead of t squared. And I need to multiply by the derivative of the guy up top, which is cosine of x. In this one, I might be freaking out because I don't know what cotangent is or what its integral is yet. Well, all I have to do is still plug in that top value for t. So now instead of cotangent of t, it's cotangent of x. And I need to multiply by the derivative of this guy up here, which is 1. So I'm already done. And in this last one, plug in my x to the 5th. So it's not going to be x to the 5th, the whole thing cubed. But then multiply by the derivative of that top number, 5x to the 4th. I'll just simplify it from there. So it'll be x to the 15th times 5x to the 4th, which becomes 5x to the 19th power. And you might have noticed here, these numbers on the bottom, they don't mean anything. It just needs to be some number. No x's or anything like that. But no matter what number it is, you can always just get right back just by doing this operation of plugging in. And you're guaranteed to see at least one, if not two, of these questions pop up when it comes time to take the AP test.